Okay, then we have question 9. Says given f of x is equals to x squared, determine the minimum distance between the point 10, 10 and 2 and the point on f. So I've illustrated that point over here with the dot, and we need to find the minimum distance from this point to our function. So that could be somewhere like this. At this point in maths, you might have done a few examples that require you to understand that the minimum distance between 2 points is perpendicular to those, or the minimum distance between those lines, between any 2 points that you want to measure the length of, it will be perpendicular from one of the sides. So this could be another example I remember doing from one of the past papers was where we had to find the minimum distance of a hyperbola to the origin. So we wanted the minimum distance from the origin to the hyperbola, and this can't be something like that, nor could it be something like that, but rather it's the minimum distance which would be perpendicular to the tangent at that point on the hyperbola, which is a bit difficult to draw, but something along these lines, something like that. It has to be perpendicular. So same thing for this case as well. We're gonna have to draw a tangent that is perpendicular at that point. Oopsie. So something like that, where that is tangent. Then remember this distance from this point, we can call it point A, and to our function of f over here. This can vary from a lot of distance, so it could be here. This is just describing the distance. This is not the minimum distance, but what we need in order to figure out the minimum distance is just the general formula for the distance between that point and our function. So we have to understand that our point and our function are going to meet at this point there, at some point. Since we don't know where it is, we can just say x is 2. Y, we could put y, or for more intuitiveness, we could put x squared, because we know y is equals to x squared in this example. So if we find x, we'll find y at that point. Then let's see. Our next step will now is to formulate the distance formula. So using the distance formula, distance is equals to the change in x, so that would be x minus 10 squared plus y minus, since we said y is x squared, we'll replace that with x squared minus 2 for the other coordinate, and then we square it like that. Then what we can do is we can multiply out. We have two binomials here. So x squared minus x times minus 10 is minus 10x times 2, it's minus 20x, and then minus 10 squared, that's 100. Same thing for this one. X squared will be x to the power of 4. X squared times negative 2 is minus 2x times 2, that's minus 4x. Then lastly, minus 2 squared, that's plus 4. I'll just extend this. Then we can continue trying to simplify this. So we have a x squared here, and we have a x to the power of 4 and then x to the power of 2. So if we write it in order of powers, we will have x to the power of 4. Then since this is the only x squared, this one should be minus 4x squared actually, because we said minus 2 times x squared is minus 2x squared, and times 2 is minus 4x squared. So that is x squared minus 4x squared, that's gonna be minus 3x squared. And then we have the 20x, and that's alone, so minus 20x. And then 100 plus 4, we can say plus 104, like that. So this is the formula that describes the distance between our 2 points. So between A and any point on our function, we can get the distance for any x value. So for this x value, we could get the distance. For that x value, we could get the distance. But we want the x value that determines the minimum distance. So what we have to do is we have to take the square root, or not rather the square root, but the derivative of this. So to get the first derivative, so to work out the derivative, we need to find the minimum value of what's inside the square root here. So we want the derivative d over dx of x to the power of 4 minus 3x squared minus 20x plus 104. And we want to equate this to 0, because we know that when the distance is minimum, our first derivative is 0, because what this will describe is the stationary point of our first derivative, and we usually know that's the point that describes either the minimum or the maximum, in this case the minimum, since maximum would probably be infinity. So from this, we can do our little procedure. That's going to give us 4x squared for the first one, 4x cubed, minus 3 times 2 is minus 6, x, 2 minus 1, that's 1, and then we have minus 20. And we say this is equal to 0. Then again, you get to this point, you have a cubic function. You want to find the values of x that give you 0. There are two methods that you can use, though one that's most advised and most widely used is guessing. So you want to guess your first root. So you try numbers between minus 1, 0, 1, 2, or minus 2 if that doesn't work, or 3, or minus 3. Usually one of these is usually our roots. They don't usually stray too far from these values. So if you actually do this, you'll find that by putting x as 2, we'll return a 0. So that means 2 is one of our solutions. Then we'll use some kind of weird division in order to find out the rest of the roots if they exist. So in this case, we have this 2. We now have to put the coefficients of our cubic function in order over here. So for x cubed, we have 4. And then there is no x squared, but that's only what it looks like. X squared is actually there, it's just that its coefficient is 0. So make sure you go in the correct order. And then after, let me just put a little space there. And then for x, we have minus 6. And then for d, we have, or the constant, we have minus 20. So always make sure you have 4 coefficients over here, then you can start. In order to know that you've done this method correctly, you should start on a 0 and end on a 0 as well. So the procedure is as follows. We take the number on top, add it with this number to get 4. Then we take 4 multiplied by 2, we get 8. Then 8 plus 0, we get 8. 8 times 2, we get 16. 16 minus 6 gives us 10. Then 10 times 2 gives us 20. And 20 plus negative 20 gives us 0. So if we end on that 0, then we know what we've done is correct. Then what does this describe? What's left? So we have 4. This would be the coefficient for x squared. The 8, that would be the coefficient for x, and the 10 will be a constant, and this will be equal to 0. So basically what this means is this now simplifies to, not forgetting this solution that we already got, we have x minus 2. If you don't understand where x minus 2 comes from, just take this a step back, take 2 to the other side, you'll find it's x minus 2 is equal to 0. So that's a solution. And this one as well, we rewrite it like that next to that one. So 4x squared plus 8x plus 10. So here, ideally we want only one solution, to be honest, or we want the other one to be invalid, or the other two. So what we do is we try to figure out the nature of these roots over here. Because if you understand the concept of the question, there should only be one x value that gives us a minimum distance. So in that regard, if you work out the nature of these roots, so if you take this and work out the nature of the roots. By nature of the roots, I mean the formula b squared minus 4ac. It tells us if the roots exist, they don't exist, or if they're equal or rational or whatever. So b squared in this case would be 8 squared minus 4. A is 4, c is 10. This gives us a value of minus 96. And this means that there are no roots because whenever the discriminant, which is what this is negative, that means the roots don't exist. That means your only solution here is that x is equal to 2. And if x is equals to 2, it means for that point on the on our parabola, this will be 2 and 2 squared will be 4. So basically determine the minimum distance between the points. Now we can easily plug in our distance formula, or we can just plug x back into this formula and work out what the answer will be. So the distance in this case is equal to the root, oopsie, is equal to the root of 2 squared minus 3, 2 squared minus 20, 2 plus 104. You put this all in your calculator, you will get 2 root 17. So that's 2 root 17 units. That's the minimum length. So this is quite the difficult question. Try to not be too afraid of calculus, but in general, this type of questions, they do come, but they don't come that often. So yeah, this is it's a difficult question, so don't beat yourself up if you don't understand it the first time. Just try to re-watch the video and hopefully it makes sense the second or the third time around. That's why I put this little stick over here to show the difficulty of this question. This is how most people react to it. But yeah,